So, good morning, students. Myself, Dr. S. Vasantraj from Welltech Multitech. So, for this semester, I am handling high voltage engineering for you. So, in this video lecture, we are going to see about generation of high voltages and current, which is of unit 4. And from this unit, we have already discussed about what is voltage multiplier circuit and what are all the advantages in it and what are the disadvantages in this voltage multiplier circuit. So for that disadvantages, which is in voltage multiplier circuit, we are going for Cockcroft-Walton method. So this is what the topic we are going to see in this video, that is generation of high voltage DC using Cockcroft-Walton voltage multiplier circuit. So these are the learning objectives of this topic. So first we are going to see how the high voltage DC is generated with the help of Cockcroft-Walton voltage multiplier circuit. And next we are going to see the circuit parameters which are used in this circuit, and with the circuit parameters we are going to derive the voltage ripple. And next, similarly with the circuit parameters we are going to derive the voltage regulation of this Cockcroft-Walton multiplier circuit. And next we are going to see what are all the optimum number of stages is used to minimize this voltage regulation. So this is the circuit diagram of Cockcroft-Walton voltage multiplier. So before this, we have studied voltage doubler circuit and cascaded voltage doubler circuit, but there are certain disadvantages to that. So in cascade voltage multiplier circuit are higher voltages, which is cumbersome and it requires too many supply and isolating transformers. So it is possible to generate very high DC voltage from single supply transformer by extending the voltage doubler circuit. So this is simple and compact when the load current requirement is less than 1 milliamps, such as for cathode ray tubes, etc. So the application of this is cathode ray tube. So these cathode ray tubes, so we have a voltage double a circuit, and here the steps are added to the nth value. So like the capacitor starts from C1, another capacitor which is added there is C2. So in voltage doubler circuit, we generally have two capacitors, that is C1 and C2, and the diodes which are placed are D1 and D2. But as we goes on increasing the level for getting the higher and higher voltage, we start adding the capacitors into it. So therefore, the capacitor level which reaches here, that can be up to C2n minus 1 and C2n. Similarly, the diodes which are added there can be added up to D2n minus 1 to D2m, and across that the load resistance can be added. So you can see there is a load resistance which is added with the increase in the capacitors from C1 to C3, C4 and so on up to C2 of n. The diodes which are added are D1, D2, D3, D4 and so on, that is from up to D2n. So we have this particular circuit called voltage multiplier circuit, where we need one transformer. The input to that has AC supply. The output from that as across capacitor, we get the double of the voltage, as we already explained in the previous lesson. So this voltage becomes twice of V with respect to ground. The voltage across capacitor C4 with respect to ground, that voltage becomes 4 times V. So voltage across capacitor C4 with respect to ground, it becomes 4 times V. Same way, voltage across next level, if it says C6, then the voltage will be 6 times V and so on. So that the voltage can be multiplied so that is simple and compact. When the load current requirement less than 1 milliampere. And the example already said as cathode ray tube. So wall type pulse generator may be used instead of conventional AC supply, and that circuit becomes compact. So therefore, we are going to use this particular circuit, which is shown in the diagram, that is called as Cockcroft-Walton voltage multiplier circuit. Now in this figure, the first stage, that is C1 D2 and C1 C2, and the transformer is identical as in the voltage doubler circuit, which we have studied for higher voltage of 4, 6 up to twice n of input voltage V. The circuit is repeated with cascade or series connection. Thus the capacitor C4 that can be charged to 4 V max and capacitor C2n can be charged to 2n V max. So voltage across C2 will be twice of V. Voltage across capacitor C4, that is 4 times V, or say V max. For better understanding, voltage across C6 of next stage is 6 times of V, or it is V max. If it is C twice N, the voltage will be 2N. You can see here the 6 is repeated here, the 4 is repeated here, which is across C4. So the capacitor, we are getting that much of voltage across the same capacitor. Therefore, if the capacitor is C2N, then the voltage will be twice and V max. But the voltage across any individual capacitor or rectifier is only 2V max. So if you say voltage across C4 only will be 2V max. So how we measure this V max? This particular voltage is measured with respect to ground or with respect to earth terminal. So next we will see the waveform of this voltage multiplier circuit. So here are the output waveforms of voltage, that is Cockcroft voltage multiplier circuit. So these concepts related to waveform which are shown in the figure, and this is the schematic current waveform across the first and last capacitor of the cascade voltage multiplier. Then this is the voltage waveform across the first and last capacitor of the capacitance voltage multiplier circuit. So in this case, again you will find there is a drop in voltage, and that voltage is almost double every time. That voltage is almost double every time. Okay, so now I am going to give you the equation so that the equation you can solve the numericals. So the ripple voltage is given by this equation. So the voltage across capacitance C2 is sum of supply voltage and voltage across capacitance C1, and the mean voltage Vc2 is less than the peak positive voltage of sum of, that is VAC plus Vc1. The mean values of voltages across capacitors C2 to up to C2n can be derived in similar manner. So this shows the circuit operation. Already we have discussed about the circuit operation of this Cockcroft-Walton method, and so again we are going to discuss about the circuit operation of this. So the first stage of Cockcroft-Walton voltage multiplier consists of voltage doubler circuit formed by rectifiers D1, D2, that is diodes D1, D2, and capacitor C1, C2, and transformer T. So this is the simple voltage multiplier circuit that we have already discussed. And similarly, a number of voltage doubler circuit are shown to be added in series or cascade to obtain higher voltages. If n number of stages are added, then peak DC voltage developed will be 2n times the peak secondary voltage of high voltage transformer. And similarly, the capacitance C4 is charged to 4V max, and similarly capacitor C2n will be charged up to 2n V max with respect to ground. And the rectifiers D1, D3 up to D2n minus 1 conduct during negative half cycle, and similarly the rectifiers, that is diodes D2, D4 and D2n will be conducted during positive half cycle. And the voltage across capacitor C2 is sum of supply voltage and voltage across capacitor C1 will be V. The mean voltage VC2 is less than the peak positive value of sum of VAC plus VC1. And this is the current waveform of this doubler circuit. So these are the capacitance current and the current which is flown in each capacitance, that is from C1 to up to C2n. And the total ripple voltage which is obtained during this Cockcroft-Walton method is del V total will be equal to IL divided by FC into n of n plus 1 divided by 2. So here IL represents load current from rectifier, and similarly F is the supply frequency, C will be the equal value of capacitance in each stage, and n represents total number of stages. And this is the voltage equation that is voltage regulation equation which is derived for this Cockcroft-Walton method, which is del V will be equal to IL divided by FC into 2 by 3 n cube plus n square by 2 minus n by 6. And the optimum number of stages for minimum voltage drop will be n optimum will be equal to root of V max FC divided by I. So V max represents peak rated transformer secondary voltage. So as of now, we have discussed about Cockcroft-Walton method and its operation, working principle, and the waveform which is generated due to this Cockcroft-Walton method. And at last, we are going to see the summary of this voltage doubler circuit. So to obtain very high DC voltages, Cockcroft-Walton voltage multiplier is used, and the maximum output DC voltage obtained using n stages circuit will be less than 2n Vmax due to voltage regulation, and it is economical to use high frequency and low value of capacitance, which is used to obtain minimum ripple voltage.